In this videotape, we will learn how to solve exponential equations. Okay, now, you have seen examples of equations involving powers or exponents. This was the simplest type, when you have like x squared equals 27. Okay, and you know that you can solve this by taking square roots of both sides. X is plus or minus the square root of 27. Okay, which is a little over, plus or minus a little over 5 here. Okay, now what we have in mind in this videotape is what to do when the variable is in the power. For example, if we have, say, 2 to the x is 27. This is a slightly different problem. Okay, this is what you already know how to do. Okay? The variable is the base here. We have x squared is 27. We take square roots of both sides, or if it was cubed, x cubed is 27. You take cube roots of both sides. Here we get x is plus or minus the square root of 27. Now, the question is what to do here. We've got the variable up there in the power, or in the exponent, this kind of equation. Okay, now the trick is to use logs. What we can do is take logs of both sides here. Log of 2 to the x power is the log of 27. Well, why did we do that? We did that because there's a property of logs that says the log of something to a power is equal to the power times the log of the something. So therefore, this is a way of getting that power, that the variable that's in the power, down in front. Okay? We'd like to get that variable out of the power, out of the exponent. We take logs, common logs of both sides here. We have log of 2 to the x power is the log of 27. We can then use properties of logs that says the log of, say, x to the r power is r log x. So the log of 2 to the x power is x log 2. Okay, we're almost there. If x log 2 is equal to the log of 27, and when I say this, of course, these are all logs to the base 10 common logs, we can divide both sides by the log of 2. And we get that x is equal to the log of 27 divided by the log of 2. Okay, now even if you have a calculator, I realize a lot of people think logs are not that important because they have calculators, you still need to know enough about the properties of logs to enable you to get it to this form. Because you have to know that if you took logs of both sides, the x would come down in front. X could then be found by the log of 27 divided by the log of 2, which you can, if you want, find in your calculator, or you could use log tables, and that's what we're going to do. We're going to look them up in log tables right now. Okay? In an earlier videotape, we learned how to find the common logs of numbers. Remember, your tables are in the back of your book, or you can get a table from the person who's running the math lab. Okay? This is equal to. Now, the log of 27 we would write as a log of 2.7 times 10 to the first power. And the log of 2, that's all right. In other words, the idea is we have to write it as the log of a number between 1 and 10. That's what our tables are good for. Okay, times 10 to some power. So we have here the log of 2.7 plus the log of 10 to the first power divided by the log of 2. Let me just rewrite that up here. The log of 2.7 plus the log of 10 to the first power divided by the log of 2. Okay, now, the log of 2.7, we can find that in our table. We look down to find 27 across to 0, because this is 2.70, and we get 0.4314. And we add to that the log of 10 to the first power. This is the log to the base 10 of 10 to the first power. That, of course, is just 1, the power. It's the power that you'd have to raise the base to get 10 to the 1. Of course, that's the first power. Divided by the log of 2, which is like the log of 2.00. So we look down the left side till we find 20, and then a cross for 0. And we get that The log of 2.00 is 3.3010. Okay, so once again, this is like 2.0, so we look down the left side to 20 and across to 0. Here we look down the left side to 27 and across to 0. Okay, so x is 1.4314 divided by 0.3010. We can do that calculation. We get about, it's approximately equal to 4.76. Okay, this, and as I said, if you want to use calculators whenever possible, fine. I mean, you can use a calculator in here. You could also use a calculator to get the log of 27 divided by the log of 2. But you have to know enough about properties of logs to understand that the answer, x, is the log of 27 divided by the log of 2. Let's see if this answer makes any sense. Remember, the question was 2 to the x is 27. We get an answer of 4.76 about. It makes some sense because, after all, 2 to the 4th power, 2 to the 4th power, 2 times 2 times 2 times 2, that's 16. 2 to the 5th power, that's 2 times 2 times 2 times 2 times 2, that's 32. It's 2 times 2 to the 4th power. And our answer here, 27, our thing here, 2 to the x, 27. 27 fits in between 16 and 32. In fact, it's a little closer to 32. Well, it's closer to 32. We would expect, therefore, an answer for x between 4 and 5, but closer to 5, and that's exactly what we got. Between 4 and 5, but closer to 5. So the answer does make sense. Just one word of caution here. This is not the log of 27 minus the log of 2. Okay, don't confuse your properties of logarithms. The log of 27 minus the log of 2, that's the log of 27 halves. The log of a fraction is the log of the numerator minus the log of the denominator. But this is not what we have here. We have the log of a numerator divided by the log of the denominator, and there's nothing much to do with that except leave it like that. The log of a fraction is the log of the numerator minus the log of the denominator, but that is not what we have here. Here we have the log of something divided by the log of something else, and that can't really be simplified like this. It just has to be worked out in that form. This time I want to solve this equation. 3 to the 2x plus 1 is equal to 27. Okay, same way. I'm going to take logs of both sides. In fact, if you'd like to try to work this out on your own, be my guest. You can shut the machine off, and when you finish the problem, turn me back on and see how you did. Okay, what I'm going to do is take common logs of both sides. The log of 3 to the 2x plus 1 power is the log of 27. This enables me to bring the variable in the power down in front. This becomes 2x plus 1 times the log of 3 is equal to the log of 27. And I can divide both sides by log 3, giving me 2x plus 1 is equal to the log of 27 divided by the log of 3. These are all logs to the base 10. Okay, let's see what we can do here. Let's get that. 2x plus 1 is the log of 27 divided by the log of 3. Well, going to use our tables. The log of 27, I'll write that as the log of 2.7 times 10 to the first power. And the log of 3 is just that, the log of 3.0. So 2x plus 1. I'm not going to bother doing anything with the left-hand side right now. On the top here, we have the log of 2.7 plus the log of 10 to the first power. Over the log of 3.0. Now, the log of 2.7 is found in your table. You go down till you get 27 and across to 0. And we get that the log of 2.7 is 0.4314. We found that, of course, in the previous example. And then we have to add the log of 10 to the first power, which is just 1. The log of 10 to the first power to the base 10 is, of course, just 1. Divided by the log of 3. We go down the left side so we find 30. Okay, and then across to 0. And we get 0.4771. And when we do this division, we get about 3 for our answer. 1.4314 divided by 0.4771 is almost 3. Okay, so we have 2x plus 1 is 3. 2x equals 2, x equals 1 as an answer. And in fact, if you check this in the original equation, it does come out exactly equal to 1. If x is equal to 1, you get 2 plus 1 is 3. 3 cubed, of course, is 27. Okay, so it does happen to work out exact. In fact, in this particular problem, we have another way of solving the same problem. This is a special kind of exponential equation problem. We could have actually done it without logs, where it is possible to write both sides with the same base. You see, 3 to the 2x plus 1 equals 27 can be written as 3 to the 2x plus 1 is equal to 3 cubed, which is 27. When you have two things equal and they have the same base, you may equate their powers as well. You get 2x equals 2, x equals 1. Okay, but this is only valid when it is possible to write the left and the right-hand side, okay, with the same base here. Like 27 was 3 cubed, something we could do very easily, and then we can equate the powers. Okay, if you cannot easily do that, then you have to resort to this kind of a technique, where you take logs of both sides. Okay, you take logs of both sides, you get the power down in front, and you solve for the power, and then you get x. Okay, only because 27 happened to be 3 cubed, we had an alternate method of solution here, which worked very nicely. And that brings us to the end of this tape.